Lesson Overview 203, Circumference and Area of a Circle. In our last lesson, 202, we covered the circumference of the circle. Now we're going to determine the area of the circle using the formula. Define the terms of circle, explain how to derive the formula for the area of the circle. So by exploring the area of any regular polygon inscribed in a circle, you can derive the formula for the area of a circle. As you're looking through the series of inscribed regular polygons, notice that as the number of sides becomes infinitely larger, the polygon takes the shape of a circle. The regular polygons are divided into isosceles triangles. Let's now consider just one of the triangles with the following variables. S is the side length of the polygon, R is the radius of the polygon, and H is the height of the triangle. Using that formula for area of a triangle, we see that area equals half times base times height. And the triangle shown here follows these steps to derive the formula for the area of a circle, where S is the side, H is the height, and R is the radius. Use the isosceles triangle from a section of any regular polygon inscribed in a circle to derive the formula for the area of the circle. Notice we're going to state the formula for the area of the triangle first. So area of the triangle is half of the side, also known as the base, times the height. We're going to define the area of the polygon by saying area equals half times the base times the height. This gives us n, the number of sides, where the area of a triangle is multiplied by n. The product is the area of any polygon. So notice that now we went from a triangle to any polygon. We're going to rearrange the formula. We did this with Pythagorean theorem when we knew the hypotenuse and we were looking for the leg. Anytime that you move a formula around by dividing or multiplying, or in this case, all we're doing is literally moving positions because multiplication is associative. So I can move it in any way that I want to. So here, we're going to go ahead and multiply this S times the N, and then we're going to divide the H by 2. Each of the terms is a factor because multiplication is commutative. You can rearrange the terms. Since S is the length of a side of the polygon and N is the number of sides for the whichever polygon we're talking about, we call that the n-gon. N times S is the perimeter of the polygon. Remember, as the number of sides of the polygon increases, the polygon takes the shape of a circle. Therefore, the value of the perimeter of the polygon will approach the value of the circumference of a circle. As a result, N times S becomes 2 times pi times the radius. We're going to go ahead and drag point C towards point A to reduce the length of S. The height of the rectangle and the radius of the circle become equivalent. As a result, H becomes R, the radius. So notice that this side and this height right here, if I drag this along the edge, it has now become long enough to become the radius. Therefore, the area of a circle is pi r squared. You can determine the area of a circle with the radius using that formula. Area is equal to pi r squared. Remember, the exact area of a circle will have pi as part of the answer. And to approximate the area of the circle, we're going to use 3.14 for pi. So here we're going to find the area of the circle if the radius is 10 centimeters, and it's asking us to use 3.14 for pi. So we know that the formula is area equals pi times radius squared. Think back to your PEMDAS days. What do you have to do first after you substitute the values? So I'm going to go ahead and substitute the values here. I have area. Remember, we're finding it in terms of 3.14, so that's going to be approximate. That's why we get these squiggly lines. So we're going to say pi, 3.14, times radius, which is 10, because that was given to us, squared. So the first thing that we have to do is our exponents, because there's nothing inside of our parentheses. So 10 squared, or 10 times 10, is 100. Now we're going to say 3.14 times 100, and we get that the area of a circle with a radius of 10 centimeters is 314. Here we're going to find the exact area of a circle. Remember, exact area, or in terms of pi, means that we're going to keep the pi symbol. So area equals radius squared. Notice that they did not give us the radius. They gave us the diameter. What do we do to find the radius when they've given us the diameter? Well, we know that diameter is 2 times the radius. So we're going to divide both sides by 2 to find the radius. So diameter divided by 2 equals radius. Plug in 12 for the diameter, and we get diameter 12 divided by 2 equals radius, which is 6. Now we're going to plug in that 6 right here for the radius. Area is equal to pi times 6 squared. Again, I'm going to go back to my PEMDAS days. There's nothing that I can do mathematically inside of my parentheses, so this just means multiplication, but I do need to do my exponents first. So 6 squared is 6 times 6, which is 36, and they asked me to leave it in terms of pi. So my area for a circle with a 12-foot diameter, 6-foot radius is going to be 36 pi feet squared. If you have any questions about this lesson, please feel free to text me or send me an email.